Note the warm spoon also gives up much of its heat, using conduction, to the air surrounding it that touches the spoon. The spoon becomes cooler and the air warms, but only for a short distance near the surface of the spoon. Heat transfer slows in the air near the spoon and cup. That's because the conductivity of air is very low when compared to the conductivity of metals, water, and many other materials. The cooler refrigerant liquid enters a small refrigerant line to return to the evaporator. To complete the cycle, the liquid is reduced in pressure by a small orifice and starts the evaporation cycle again. This pressure-dropping orifice is needed to help lower the pressure above the refrigerant. As long as the compressor runs, the cycle continues. This is the cooling cycle in its simplest form. An evaporator for the boiling, the compressor, the condenser, the connecting lines, an orifice for pressure reduction, and the liquid refrigerant. Pure refrigerant in an enclosed system follows a precise vaporization curve that determines the operating temperature of the evaporator in the system. For precise control of evaporator temperature, refrigerant must be pure without contaminants. Additionally, the purity of the refrigerant also determines the rate at which the returning refrigerant vapor condenses on the high-pressure side of the refrigerant circuit. The moisture remaining in an operating system does more than change the operating performance on the refrigerant circuit. Moisture mixed with oil in the shell of a compressor weakens the lubrication ability of the oil, leading to higher friction and shorter life for the compressor. Loss of lubrication ability of an oil from moisture absorption is even worse if the oil is a POE type oil typically used with 410A refrigerant. A fundamental rule for charging will get the technician close to the condition of charge. If superheat is high and suction pressure is low with low subcooling and low condensing pressure, the unit is likely undercharged. An additional option is to run a cooling capacity check using the temperature difference across the evaporator, the airflow over the coil, and a psychrometric chart to demonstrate the capacity loss that will add to operating expenses. Once a neutral flame appears, stop increasing the oxygen flow. A neutral flame has a single inner cone approximately 3/4 of an inch in length. Higher pressure setups have a slightly longer inner cone. A flame that is properly set up for the work to be done is large enough to wrap around the tubing and fitting of the joint. The flame setup is complete and the rig is ready for the actual brazing operation.